This is our first question on the Unit 3 assignment. It says use this diagram of the triangle PQR, so there's P, Q, and R, to make a matching statement with its term from the drop-down menu. Terms may be used more than once or not at all. Okay, so we're looking for sine of Q. So here is Q, the angle Q must be inside here. And if we're looking for sine of this angle, sine of an angle, in this case I guess it's Q, is equal to opposite over hypotenuse. The opposite side is Q, and the hypotenuse is, well, the hypotenuse, R. So I can't choose from the drop down on a picture, but it'll be Q over R. Next, which side is the hypotenuse? Well, that was identified to answer the first question. Hypotenuse is always opposite the right angle, or the longest line in the right triangle. That's side R, or we could talk about it as maybe, so we could say R, or we could identify it as the line segment QP, or PQ. Any one of those would identify that side. Small r, or the line segment PQ or QP. I'm not sure what's in there. I think it's one of those. If we're looking for tangent of P, here's P. Angle P is right there. And the tangent of angle P is opposite over adjacent. The opposite side is little p. And the adjacent side is little q. So that would be P over Q, little p and little q. And last, the side opposite to angle Q. Angle Q is right there, and the opposite side is little q, or we might say, just like before, we might identify it as either the line segment PR or RP. So one of these ones, little q, PR, or RP, would all identify that line. For the next question, a balloon is 300 meters directly above the road. I'm going to draw a little triangle here. Well, I'm not going to draw it, but whatever. 300 meters directly above the road. So there's a balloon up here. Oops, there's a balloon up here. That's the balloon. And this side here is 300 meters. It's 300 meters up. A car stopped further back on the road, so there's a car right there. That's the car. Looks up and sees the balloon at an angle of elevation. Doesn't say what the angle is though. If the car's line of sight is exactly 550 meters to the balloon, then what is the angle of elevation to the nearest degree? So we're looking for this angle here. The car is here, they're looking up at the balloon, and it says the line of sight, so where they are looking, which is right along here, that's the hypotenuse, is 550 meters. Don't ask me how they measured that. I bet they didn't. Maybe with lasers. What is the angle of elevation? So for this angle here, we know this side, which is the opposite, and we know this side, which is the hypotenuse, and opposite over hypotenuse points us towards using sine. So if we use sine of the angle, it's opposite over hypotenuse, and we're looking for the angle, then the angle itself will be the inverse sine of opposite over hypotenuse, which is the inverse sine of 300 over 550. For the meters, they're going to cancel themselves out nicely. I know a lot of you don't do this. Write in the meters and then cancel them out. There's a reason that I do, though. It's come back to bite me a lot of times. So the inverse sine of 300 over 550 is 33 to the nearest degree. It's 33.055, but 33 degrees. So this angle right in there is 33 degrees. Okay, I'll stop this recording, go on to the next couple of questions.